Okay. And so what this means is that when you compare the actual overheads to the absorbed overheads, then you can get the over and under absorption of overheads. Why do you always get the computation of over and under absorption of overheads wrong? It's because you don't understand the concept of overheads. And so today I'm going to use this particular question to explain to you the very foundation of overheads up to under and over absorption of overheads. So looking at the question on the left and the solution on the right, I explained to you that for this particular section on the left, we have allocated overheads for indirect materials because there is cost for each cost allocated to each department. So when we come here, we have indirect materials allocated. The total is 11,000. When you sum all of this, it is 11 million because all these are in thousands. So it's 11 million. Now 5 million here, 3 million for B, 1 million for C, 1.5 for T, and 500,000 for M. Now I'm going to exclude the three zeros, and I hope you understand it. So these costs, indirect material cost, is allocated because when you look at here, they are allocated. Okay, indirect labor, it's also allocated. 10 million, 4 million, 5 million, 500,000, 2.5 million. And so the costs are allocated here, indirect labor, and they are allocated. And the total is 22 million. I hope you get the understanding. Okay. Now, electricity has been given as 600,000 here. Now, that is not allocated, so we need to apportion. It's here that we have to come to the basis of apportionment given here in the question here. Now, electricity is shared by the area or in square meters. So we allocate its area in square meters. Now, when you come here, you see that the area in square meters, 20 square meters for A, 30 square meters for B, 10 square meters for C, 15 and 25 for T and M respectively. So in order to compute what is allocated to A, we will take 10, okay? So this is stated over here. So in other words, we can find the total over here, okay? So the total is going to be the sum of all of this. So we sum all of this, okay? So we are going to get 100. I hope you get me. Now, what this means is that when we take 20 and divide by 100 and multiply by 600, okay, 20 divided by 100 multiply by 600, we are going to get 120. For B, we are going to get 30 divided by 100 multiplied by 600, and we are going to get 180. And the same applies to C, T, and M. I hope you get it. Now, we go to rent, which is 3 million. So rent is 3 million. Now, the same basis of apportionment is used, area in meters. And here we are going to, the total cost is 3 million. So we are going to apportion. We're going to use the same approach. 20 divided by 100 times 3 million. And that is going to give us 600. 30 divided by 100 times 3 million is going to give us 900,000. I hope you get me. And the same applies to C, T, and M. If you don't understand, for C is 6 divided by 50 times 3 million, giving us 300,000. Okay? So we go to insurance, and the book insurance, we use the book value. Insurance staff, we are going to use the number of staff. The canteen, we are going to use number of staff, and other overheads, we are going to use percentage. So percentage is here, other overheads, and the percentage allocated is here. I hope you get it. The percentage allocated is this one. Okay. Now, what means is that this is 30%. So basically, what this means is that when we take 30%, which is 0.3 divided by 1 times 2 million, we are going to get 600,000. Okay, we are going to get this 600, sorry, we are going to get 600,000. Now, when we go to B, we are going to get 20 divided by 0.2 times, oh, sorry, divided by 1 times uh, times 2 million, which will give us 400,000. Okay, so that is basically what you're going to do. So we have the allocated, which is this one. We have the allocated indirect material. So then the unallocated are here. Then we use the basis of apportionment to share, and this one we have allocated it. Now, after here, we are going to look at the total of the overheads. Now, pay very close attention. Now, after we have allocated and shared, we are going to total. So we are going to sum for indirect material, indirect labor, electricity, rent, insurance, canteen, and other for every department. For every department. So this one is the total for all the overheads. And for department A is 18,680. Department B, 9,820 in millions. Then 6,976 for C, 3,464 for T, and 5,464 M. Okay, so the first part of the question has been fulfilled. That is the A part. Okay, so this is the A part. So let me put here A. Okay, so that is the A part. So we've gotten the total overheads. That is the total overheads for each cost center. Now the B part is saying we should reach charge service department cost to production department using or simultaneous or algebraic. Wait a minute. We are not going to use simultaneous or algebraic. I'll tackle that in another video. But what we are going to use is the reciprocal distribution method. The reciprocal distribution method. Okay. Now for the reciprocal distribution method, we are going to share the service department. Let me insert a row up here. So these two departments are called the service department. So let me put something here. Service slash support department. And these two is production department. Okay, so let's highlight here. So what we are basically going to do is share the service department. Now, when you look at this particular section, you realize that the one highlighted in green, you realize that the total for service department T is 3464, and for service department M is 5460. Now, let's come to the left side. Okay, let's come to the left side. On the left side, it says that pay attention to this utilization of service department by production department according to technical estimates is as follows. So I explained to you earlier, A is using 30% of T, B is using 40% of T, C is using 20% of T, T itself cannot use itself, and M is using 10% of T. Now, when you look at this particular table, I mean this particular side of the table, you will see that for T is 0 and for M is 0 here. So in order to start, you start with T department first before you go to M department. Okay, so for T department, the cost that needs to be shared is the overhead cost, which is 3464. Now, the percentages has been given to you. And when you add these percentages, you are going to get 100. So for department A, it is going to be 30% over 100%. Okay, so let me highlight this one here. 30% over 100% times this cost, that has been given to you, this particular cost highlighted. And that is going to give you this particular cost that is highlighted. And that is going to give you 1039.20. Then when you go to B, it will be 40 over 100 times 3464. And that will give you 1385. Then C will be 20% over 100% times 3464, giving us 692.8. Then M is 10%, 10% of 100%, giving us 346.40. Now, after that, we are going to share the service department M. That will be the second. So the percentage has been given to you here. Okay, 30%, 40%, 20%, and 10%. Now we are going to share the service department M. And this is where I want you to pay particular attention. Now, when we shared the T department, M department got a percentage. So this is the percentage they got, which is 346. However, their overheads allocated or totaled for them is 5460. So what we are going to do is total these two. Okay. So when we total these two, okay, let me use a lighter color. When we total these two, we are going to get this. Okay. So the total of these two, they will share for all A, B, C, and T. Now, when we share, that one is going to get a percentage. A is 40%, given here. A is 40%, B is 30%, C is 25%, and T is 5%. So 40 over 100 times 5806 will give us this number. Then 30 over 100 times 5806 will give us this number. And 25% over 100 times 5806 will give us this number. And 10%, or sorry, 5% of 5806 will give us this particular number. I hope you get it. Okay. Now, you see, service department here has also got a value which is 290.32. 290.32. Now, we are also going to share it. And that is the reason why we call it reciprocal distribution method. Reciprocal distribution method. So we are going to share that using this same way, the T service department. So we share for A, we share for B, we share for C, and we share for M. Then we bring the M down to 2900, the M which was allocated 2903, we are going to share it. So in order to share it, you bring it down before you share it to the various departments. Okay. Now I'm supposed to put that into brackets, but I decided to highlight it so that you see it well. So when we share with this particular percentages, we are going to get 11.61, 18.71, 7.26, and 1.45. Now this is where I want you to pay very close attention. Now 1.45 is a insignificant amount. It means that it is it is not insignificant. It's 1.45 times 100,000. So that is going to be 14,500, right? Or 145,000. Sorry, 145,000. So 145,000, since this amount is very small, looking at if we remove the three figures, is 1.45. So in that particular instance, we are not going to share for M department. We share this cost. We share this particular cost for A, B, and C. Okay, so we use this particular ratio. Now, when you check the ratio, you see that T service department had 10, but I've removed the 10 because the 10 is for M department. The 10% is for M department. So since we are not going to share for M department because the number is very small, okay, we are going to exclude their 10% and use 30%, 40%, and 20%. So 30 over 100 times 1.45. Okay, then 40 over 100 times 1.45, and 20 over 100 times 1.4 will give you 0.2. I hope you get me. Now, someone will ask, why didn't you make it 30 over 90? Sorry, the 10% is part of the computation. However, we are excluding it, so we assume that it's 100%. So don't exclude it and make it over 90. Make it over 100. 30 over 100, 40 over 100, 20 over 100. Now, when we share, we are going to get for department A, department B, department C. I hope you get it. Now we've shared the service department cost to the production department. This service department, we've shared this service department cost to this production department, to this particular production department. Okay, so let's get back to our normal white color. Okay. Now, what this means is that we can now total the cost of the service department. So we are going to do the sum of all the costs to each production department. So when we sum for product department, we are going to get these particular numbers that is highlighted in yellow. Okay, great. Now, what is left? Now, since we've got the overheads at the top over here, the overheads at the top, which was allocated and apportioned, then after we apportion the service department, we got this total. We are going to find the total overheads. And that total overheads is going to be the total overheads that was allocated and apportioned and the share of the service department to the production department. So that is going to be the addition of the total of service department cost and the actual overheads. And for department A, we are going to get 22 or 40.90, and B is 13,072.94, and C is 9186.01. I hope you get it. Now, this is the part. So the B part is also settled using the reciprocal distribution. Let's go to the C part. Compute overhead recovery or absorption rates in each production department. Okay. Now, how do we compute overhead absorption rate? There is a formula, and the formula is very simple. Budgeted overheads. Now, remember, I said that the estimated means budgeted. Okay. So the budgeted overheads divided by the estimated labor hours. Okay, so let me say basis divided by basis of apportionment. Apportionment. Now, what this means is that there are several bases of apportionment that you can use. You can use labor hours, machine hours, percentage of labor, percentage of machine hours, total units produced. All of these are bases of apportionment. But in this particular question, they said that we have to use the estimated labor hours. Labor hours. The estimated labor hours given in the particular question. And in the question, the estimated labor hours has been given down here. Furthermore, the following information is available. So you look on the right, left. Furthermore, the following information is available. Estimated labor hours 100, 250. So since the formula has been given, the budgeted overheads is brought here. Now, the budgeted overheads is what we have computed up here. So let me highlight that in, so what we have computed in yellow. Okay. Now, we bring them down here for A, B, and C. Now, what is the budgeted basis of apportionment? The budgeted basis of apportionment has been given as the estimated labor hours. For A, it is 100, B, it's 200, C is 50. Okay. So in order in order to compute the overhead absorption rate, it is the budgeted overheads, it is the budgeted overhead divided by the basis of apportionment or the estimated labor hours. So when we divide 22,140.9 by 100, we get 22.41. The same applies to B and C. So the overhead absorption rate has been given. So that part of the question C has been settled. Okay, that part of question C has been settled. Great. Now let's go to the next question. It says determine or compute over and under absorption of overheads. This is the part that I want you to pay attention. Now, To compute the overheads absorbed, we'll look at the overheads absorption rate. Okay, the overheads absorption rate computed is this. So we bring it here. Now, when we want to compute the overheads absorbed, we are going to look at the actual overheads or the actual hours spent. The question gave you the actual hours. Okay, so the overheads absorbed. So overheads overheads absorbed is equal to actual actual units. It can actual units. I want to use actual units. That means it can be in machine hours, it can be labor hours, it can be in production units. Actual units multiplied by the overhead absorption rate. Okay, and that will give you the overheads absorbed. Pay attention to this one. So the overheads absorbed given here. So the overheads absorbed is this given for each department. Then the actual units is the actual hours that was given in the question. When you look on the left is 20 hours for A, 10 hours for B, 30 hours for C. So you put that there. When you multiply by the overhead absorption rate, you get the overheads absorbed. So the overheads absorbed is highlighted in green. Okay. In the question, they say actual overheads as per account. So the actual overheads has been given here. Remember, there is there is four zeros on top. So you have to remove the four zeros. So here is 1.5 million, 6 million, and a. Okay. And so what this means is that when you compare the actual overheads to the absorbed overheads, then you can get the over and under absorption of overheads. Let me highlight in red. Okay. Now, when the so this one you are going to get. Okay, so this one is too it's difficult to see. So let me here. When the actual overheads is less than the absorbed overheads, then you get over absorption. So over absorption is where, okay, overheads is actual actual overheads actual overheads is less than less than absorbed overheads. Let me put it here. Okay, so the actual overheads is less than the absorbed overheads. Then under absorption is when the actual overheads is greater than the absorbed. So I hope you get it. So let's use this particular rule. Let's use this particular rule. So under absorption, this is the actual overheads, the one in violet. and that one is less than the absorbed. So we get under, you get, we get over absorbed. Sorry. Okay. Now, when we compare here, you realize that the actual overheads is more than the absorbed overheads. This means that we under absorbed the overheads. And the same thing applies here. When you look at here, the 8,000 is bigger than the absorbed overheads, which is 248 now. So we under absorbed. Under absorbed because we underestimated our overheads. And so we need to make adjustments. Okay. So I hope you get the understanding of this video. If you got the understanding, subscribe to this channel and share with your friends.